In this video, I'll show you how to solve the ALEKS problem called writing Lewis structures for a molecule with one central atom and no octet rule exceptions. The first thing that we want to do in this process is count up the number of valence electrons for all of the atoms in this molecule. And this is going to be based on their location on the periodic table. Everything that's in the first column has one valence electron, second column has two, and etc. The only exception to this would be helium, which has 2, and everything else in this column has 8. Hydrogen, being in the first column, has 1 valence electron. So for our hydrogen atoms, we have a total of 2 hydrogen atoms. Each one has 1 valence electron, so that's a total of 2 electrons from those hydrogens. And then sulfur, which is located over here, is in the sixth column. One sulfur atom has 6 valence electrons. And that means that altogether we have a total of 8 valence electrons. We're going to need to use all 8 valence electrons when we're drawing the structure for this molecule. Our next step is to arrange the atoms in the molecule. Typically, the first atom in the molecular formula is the central atom. The one exception to that would be if the first atom is hydrogen. So I'm just going to kind of make a note down here. The first atom in the formula, the way the formula is written, is going to be the central atom, except for if it's hydrogen. If we have hydrogen in the molecule, we almost always write it first in the formula, and hydrogen can't be a central atom. It's impossible. Hydrogen is never a central atom. So if you have hydrogen in your molecule like I do, just ignore it for a minute and move on to the next atom. That's your central atom right there. So we'll write that central atom, and then we want to arrange all of the other atoms around it like that. So the 2 hydrogen atoms go around it, and we want to connect the central atom to the outer atoms with single bonds. One of the common mistakes that students make is that they try to do something super creative, like maybe try to make a triangle out of this or something like that, and that's just not how the molecules arrange themselves. The central atom is in the middle, and then all of the other atoms arrange themselves outside of the central atom, kind of like, spokes coming off of like a bicycle wheel. We don't have that many though. So every bond that we use to connect an outer atom to the central atom, every one of those bonds contains 2 electrons. And so that means that by drawing these 2 bonds, we just used a total of 4 electrons, which means that we have 4 electrons left. Again, there's 2 electrons here, there's 2 electrons here. We used 4 electrons. Of our initial 8, we've got 4 electrons remaining. For the remaining electrons, we're going to arrange those electrons on the central atom as lone pairs, and we want to do this so that our central atom ends up with an octet, a total of 8 electrons. The central atom had 4 electrons to begin with, so we added number 5, number 6, number 7, and number 8. In doing this, I used 1, 2, 3, 4 electrons, which means no more electrons are left. We've added all the electrons that we can. The last thing that we want to do is just check all of our atoms and make sure that they have an octet. If we look at the sulfur atom, we can see it has 2, 4, 5, 6, 7, 8 electrons, which means it's happy. Hydrogen atoms don't like to have an octet. They're too small. They can't have that many electrons. Instead, they just like to have 2. So this hydrogen atom has 2 electrons. It's happy. And this hydrogen atom right here also has 2 electrons, so it is also happy.